Mr. Munjal, you are muted. Please unmute your...
Yes.
Good afternoon, sir. How are you?
Good afternoon, and I'm fine. Thank you.
Good afternoon, all. Seshu sir, it's 4 o'clock.
Please start. Please start.
Thank you very much, sir. Good afternoon, one and all. Very warm welcome to SAMVAAD, 15th edition of SAMVAAD. Today we have a very distinguished academician and an education administrator, Professor R.K. Shevgaonkar. Professor Shevgaonkar is currently Provost of Somya Vidya Vihar in Pune. Previously, he was the director of IIT Delhi and Vice Chancellor of Bennett University and University of Pune. Professor Shevgaonkar received his BE degree with gold medal in electrical engineering from Jivaji University, followed by an MTech from IIT Kanpur and a PhD from IIT Bombay. Then he was a scientist at Indian Institute of Astrophysics and Raman Research Institute in Bangalore. After doing his postdoctoral fellowship at University of Maryland, USA, he joined IIT Bombay. Here, he has occupied various positions like Dean of Student Affairs, Dean Research Mobilization, and Head Department of Electrical Engineering. He was also the founder head of Center for Distance Engineering Education Program, or as we know it as CDEEP. Professor Shevgankar's research area spans over many areas like optical communication, image processing, antennas, microwaves, radio astronomy, etc. Professor Shevgaonkar has been recipient of many awards, including IIIE Undergraduate Teaching Award, IET Awards for his outstanding contribution to optical communication, Education Leadership Award, WASPIC Award, category of Information and Communication Technology, IETE Ramlal Wada Award, and IEEE William E. Sele Award for the achievement in education. Professor Shevgaonkar is a fellow of many societies, including IEEE, INAE, National Academy of Sciences India, Fellow of Institute of Electronics and Telecommunication Engineers, Fellow of Optical Society of India, Institute of Engineers, and Maharashtra Academy of Sciences. He is also a member of International Astronomical Union and Astronomical Society of India. Sir, it is our great pleasure to have you on SAMVAAD, and thanks a lot for accepting our invitation. Before I hand over to Professor Shevgaonkar, I have a request to audience to post their queries. They can use the Q&A box in the lower right side of the screen. Sir, over to you, and thank you and welcome to SAMVAAD, sir.
Thank you. Good afternoon. Very distinguished fellows of INAE and particularly the Bangalore chapter. Professor Sheshu, Director of IIT-Dharwad, all distinguished colleagues who are joining this SAMVAAD. I am indeed privileged and honored to give a lecture in SAMVAAD because very distinguished speakers have given their talks on this forum. So I feel really privileged that I am invited to give a talk on this SAMVAAD. And these are some thoughts, which are there about engineering education, which we have been discussing for some time. But any new suggestions, can always be added. So since we are having very distinguished members in the audience, I would request toward the end of the talk, if they have any suggestions to add to my presentation, I think I would be really delighted to really do that. So the topic which I have chosen is quite general, which is the engineering education, past, present, and future. And that's what essentially I'm going to talk about, the evolution of engineering. Where do we stand today as far as engineering is concerned? And in next couple of years, or next decade, or 2 decades, or 3 decades, where the engineering actually is going to head. That's what I'm going to talk about in this talk. So everybody can see my screen?
Yes, sir.
Yeah, yes. Is the screen changing?
It is still in the first slide.
It is not changing.
Have you changed it to second slide?
I changed to second slide.
No, it shows.
It is not changing.
Could you go to presentation? Now it is second slide.
Yes, sir. Now it is second slide.
Okay, so can we see this or can we continue this way?
No problem. No problem.
Sure,
Can you go to third slide just to verify?
Yeah. Okay.
Yeah, now it has gone to third slide. No problem.
Okay, let us continue with this.
Yeah,
mode.
perfect.
But this is working okay.
Yeah.
So to make a beginning, let us first define what we mean by engineering. So we know that the engineering is a profoundly creative process of designing, and the designing has to be under constraints. So engineering is designing devices, components, systems, and the ultimate goal of engineering is to improve the quality of human life. What could be the constraints while designing these gadgets or devices or products? The constraints could be technical, they could be economical, there could be business constraints, there could be political constraints, there could be social constraints, there could be even ethical constraints when we design a product. So engineers have to really develop something under variety of constraints which are imposed by various constituents, as mentioned here. And technology actually is the outcome of engineering. So maybe engineering principles remain same, but the new technology keeps on adding as the time moves. So let us have a quick look at the evolution of engineering right from the ancient times. So the start of engineering, if you want to define, maybe it will be something about 3,000 to 4,000 years ago when the engineering actually started. And mostly that time the engineering meant the civil engineering or maybe metallurgical engineering. And these are some of the architectural marvels which you see all over the world, which were mostly created by the civil engineers and the material scientists at that time. Even many of the monuments which you see are really the marvels in India. So you see there is a pillar which is in Delhi, then there is a temple in South, then you are having this another temple which is in Maharashtra, Taj Mahal, the Rajasthan temples. Then we are having across the world, we are having the Giza pyramids, we are having the Roman architectures and so on and so on. So the engineering in ancient days was primarily civil and metallurgical engineering, and other disciplines of engineering actually came much later. And as we see, the evolution takes place here. So engineering before the scientific revolution, which we can say about 300 to 400 years from back, the engineering was mostly by trial and error. There was no great framework was provided for the engineering, and tinkering combined with imagination used to develop something, right, which were used by the civilizations for their activities. And the word engineer originates from engineer, right, which is used for a conceptualizer of engineer devices. So any person who has got some innovative ideas which you could translate to produce something, that person could be called engineer. The skills of engineer were applied to the advantage of the society. So engineering always had an objective at the back of the mind that whatever we are doing, that should be ultimately useful to the society as a whole. Now, during scientific revolution, which we can say in about the 18th and 19th century, the engineering adopted scientific approach to practical problems. And that's the time actually many of the scientific laws came, the mathematics got developed significantly, and the calculus came, the Newton's law of motions came. And on the basis of this, many of the mechanical devices and the machines were actually developed during scientific revolution time. The engineers changed from practical artists to scientific professional as technical training shifted to schools. So at that time, what was happening? Before that, there was a formal engineering training was not there. Right? During the scientific revolution, then this training formally came into the institutions, colleges, and universities, and the formal scientific training was provided to the people who could then become the professional developers of the engineering gadgets. And the information flowed through journals, organized journals, channels like journals and conferences. So before that, the exchanges of ideas were very, very limited. During scientific revolution, then the exchanges of ideas started. So the concept of journals and conferences where people would come together or whatever their scientific findings were there, they were published into the journal, which will be circulated among very wide audience. So the exchange of ideas, that became much more easy, and that actually started doing some multiplicative effect. People could build on each other's ideas and can develop very, very new innovative products. Then came the Industrial Revolution, where the human and animal muscle power was replaced by the water and steam. And that was something, a very major revolution, which we can say in about 18th and 19th century. The engineers changed from practical artists to scientific professional as technical training shifted to schools. Because before that, most of the energy which was used by essentially a muscle power which was used. It could be human muscle power or it could be animal muscle power. But ultimately, the energy was only taken from the muscle power. The major transformation came when the energy conversion process started. And that actually happened in the Industrial Revolution time, when the energy was actually given to in the form of heat, it was given to the water or the steam, and that energy then can be used for driving the mechanical devices. So that was one of the most major transformation which took place as far as the engineering is concerned. And then of course came the electricity, there was the mechanization in the Industrial Revolution time, there was mass production, and so on and so on. The engineer's role then, of course, changed to conceptualizer and designer. So earlier when we talked about engineering, the engineer was supposed to get an idea, he used to sort of create a model, he used to finally demonstrate it, he used to make the machine, he used to let it work, and so on and so on. When this systematization started taking place, and this new ideas, energy conversion ideas and something came, the developing machines and products became a job of technician. So the engineer's job became more like a conceptualizer and more like a designer. And once he gets the design ready, then he would hand it over to the technicians who would finally make it a physical model. And then that, can be again given to the engineer to see whether it is performing okay or not. Formal engineering school were established during this time. And then new terminology, more fancy terminology actually got launched. So earlier, what were the workshops? They were called laboratories now. The tinkering was called industrial research. The individual inventions were called systematic innovations, and so on and so on. So that's what actually happened during the Industrial Revolution time. Then came the next transformative age, and which was the information age, right? And which was essentially in the 20th century. The most transformative phase of human growth, that's what we can call as the information age. And we'll see that there was a catastrophic change which took place in the thinking, of human beings in this phase, which is the information age. So the research and development boomed in science and technology during this time, which was essentially the last century. Explosion of engineering outgrew the natural science research. So before this, the research, there was no great distinction between science and engineering. Maybe you could call science as the applied science if you apply to engineering, but otherwise it was considered only as a science. And then people used to do a conversion of their science for the utility of the human mankind. Whereas now, when the information age came, there was an explosion of engineering, and the scientific research, per se, the fundamental scientific research got little backseat in the sense the scientific principles came, but then there was a multifold expansion of that idea which came from scientific principles into different engineering forms. And that's what was the explosion which took place in the engineering. And engineering was stimulated by new technologies like aerospace engineering, computers, nuclear power, telecommunication, new materials, and so on and so on. So that's what essentially happened in the information age, which was essentially the last century. Now, so quickly, if I just want to tabulate, you will see something interesting. And that is right from about 3,000 years ago, which we may claim to be like the beginning of the engineering, up to 18th century, practically the engineering development was very, very limited. It was very, very primitive in some sense. So if I say up to 18th century, what was invented which could be used by the human beings in the form of some engineering modules? There could be levers, there could be wheels, springs, screws, maybe even gunpowder, which was invented before that, and so on and so on. So almost about 2,000 years, like the development of engineering was reasonably low profile. Right? Something happened, but not really significant. The actual things started changing in 17th and 18th century. So in 17th and 18th century, when the scientific revolution started, then the new ideas came, like we got telescopes, we got microscopes, we got thermometers, we got power looms, we got steam engines, lightning rods, capacitors, sieving machines, and so on and so on. Then came the 19th century, where the growth of engineering was much more, and then we could see the steam locomotives, we could see IC engines, we could see printing presses, we could see telegraph, even bicycle was invented during that time. Then we had electric motors, color photograph, battery, plastics, radio wave, even cinematography, which was there and so on. Then came the 20th century, which was the last century, where the growth was really catastrophic, if I say so. And that is because we got many, many things which transformed the world completely. One was, of course, the high-speed trains, which came. Then the better cars came, with better performance, the cars. The aeroplanes came, the vacuum tubes came, the transistors came, the telephones came, the television came, air conditioning came, optical fibers communication came, lasers came, computers were there, internet was there, satellites were there, space shuttles were there, mobile phones were there, and whatnot. So you see, the last century was really flooded with these kind of new inventions which took place in science and engineering. And then in 21st century, if you look at just last 20 years, you see there are many new technologies have been added. So high-speed networks have come. 5G is almost on the verge of implementation, and people have started working on 6G. We have e-commerce, we have e-medicine, we have online education, we have nanotechnology, robotics, artificial intelligence, machine learning, virtual and augmented reality, quantum computing, unmanned vehicles, 3D printing, Internet of Things, and so on and so on. So as we see now in last about 200-300 years, what was happening in 17th and 18th century in 100 years, practically it happened in about 10 to 20 years in 20th century. And what happened in 20th century in 10 to 20 years happens in the 21st century. So with this growth now, there is exponential growth which has taken place in the engineering, and with the, of course, with the advancement of scientific principles also, which added to the growth of the engineering as a whole. So this whole path of engineering, if you see in last 100 years, actually it is almost exponential, and it is still growing in the exponential fashion. So with this, if you ask what is engineering today, firstly, there is an explosion of knowledge in every discipline of engineering now. And engineering has become more and more specialized. So earlier, even during our time also, we have seen when we were students, much more broader things were told to us, to all the engineers. There was no segregation of civil, mechanical, electrical engineers right from day one. Later on, people in the post-graduation, they could do specialization and so on and so on. However, as the time is moving, right, engineering is getting more and more specialized because the growth of engineering in each discipline is very, very large. Second, engineering, because of this, has got now more compartmentalized. And earlier in your career, actually people start compartmentalizing themselves. So you could call, I'm an electrical engineer, I'm mechanical, and so on and so on. And of course, in last about 20 years, biotechnology has also become a part of engineering. And there are many systems which people talk about, like bio-inspired systems and implementation into engineering, and engineering helping the biotechnology programs and so on, right? That has become a trend in the engineering education. Engineering became more modeling and simulation than real hands-on. And that is something you can give credit to the computing power which is available. But at the same time, people also see that earlier engineers always meant doing something with their own hands and creating something in the physical form. Now, when we talk about engineers, most of the time they do only modeling and simulation. And if they are satisfied with modeling and simulation, maybe the job can be given to technicians to really see whether it can be implemented in practical life. So hands-on level of engineers is reducing as the time is moving, and more simulation and modeling is getting imparted to the engineers. And in India, in last 30 years, there is a technical university growth which is almost exponential. So when India got independence, that time we had only about 30 universities across the country. Today we are having almost 1,000 universities in the country. There are 5,000 engineering institutions in the country. And this expansion in engineering education has just taken place in last about 30-40 years. Before that, the engineering was not really the prime thing. Second thing what has happened in India is that we started making the universities which are purely technical universities. Earlier, engineering used to be part of the comprehensive university, right? But now we see there are institutions or universities at the state level which are purely technical universities. So at this point, with this growth of engineering over the years, let us make some observations. So first observation one can make is engineering addresses the contemporary needs. So whatever were the needs in 18th century, 17th century, engineering tried to solve those problems. Today, engineering solving the problem, which are the problems of 20th century or 21st century. Maybe some of the problems are created by the technology itself. Nevertheless, engineering objective is to solve the contemporary problems. Second, engineering depends upon the available scientific knowledge. So if somebody had asked 200 years back, the concept of internet probably would not even can be imagined. Even satellite communication cannot be imagined. Because at that time, even the scientific knowledge was not really there. So whatever engineering does, it actually depends upon what is the scientific knowledge present at that point of time. And further, engineering and society, they adapt each other. And that's what we can see in last 30, 40 years, whatever technology or engineering started giving, the society slowly kept on changing itself to accommodate that technology. And not only that, the society started demanding more and more science and technology, like in their day-to-day life. So this is like a interdependence which the society creates on the technology and the behavior of the societal changes. So what are the main challenges which engineering faces today? The biggest challenge which engineering faces today is the rapidly changing world. And last 100 years, the world has really changed catastrophically. And again, few technologies can be given credit for this. One technology, of course, is the telecommunication technology, where the whole world got integrated. And second technology is the high-speed transportation technology. So earlier, the whole world, which was functioning into their silos, now because of the high-speed transportation, there is a huge amount of mobility of the people across the world, right, which take place. And whatever change has taken place because of these two major technologies in last 100 years, this change is now practically irreversible. So even if you want to undo something, I think society has reached to a level where these changes now cannot be undone. So these are the changes which have taken place. And technology emerged at an unprecedented rate. So as we said, what was happening earlier in 10 years, now it happens in 100 years. What there was 100 years, now it happens in 10 years, and so on and so on. Technology also is changing so rapidly that the lifetime of technology has become very small now. So typical lifetime of technology, if you see in computer science, electronics, telecommunication, that lifetime is only about few years. So many times you wonder that whatever education you are imparting to the students in their degree program, by the time they graduate, many of the things are in the verge of becoming obsolete. So lifetime of the technology is becoming shorter and shorter as the time is moving. And the extrapolation of technology appears impossible, at best difficult. There is a statement which is said repeatedly by many people there. And that is true, that suppose we were asked about 20 years back that technology-wise, engineering-wise, where we would be in 2020, if this question was asked in the year 2000, I'm sure 99.9% time we would have completely failed. We would have predicted something, and today when we would have compared with that, we would see that we would have gone way ahead of what the predictions were done at that point of time. So in this technology which you are seeing, which is predominantly dominated by ICT technology, the prediction of technology is becoming more and more difficult as the time is moving. With that understanding then one can ask, what is the future of engineering? Where the engineering is going to head? So future engineering certainly will depend upon what the future world is going to be. Because if we saw the interdependence of the engineering and the society or the human being. And the future world will be shaped by the present and the future technology. So this is like an entangled problem which you are having. Technology is going to modify your life, and your modified life is going to demand more technology, which is going to come further and will further change your life and so on and so on. Right? So it is very important that to understand how the world is going to evolve, right, next 50 years, 100 years, and what way engineering is going to get shaped, right, in the scenario which is like that. So there are a couple of scenarios one can sort of imagine. One could be, there could be a next scientific revolution which might come, in next 30, 40, 50 years, right? A new technology paradigm may come completely. So today we are having a technology which is, let us say, silicon technology. Maybe tomorrow the carbon technology may come and which may change the complete thinking, of the engineering. The biotechnology may create a revolution in the societal context. So you may have the biotechnologically modified the genes and so on. The society may get completely changed. The human nature of individuals might change over the years. We don't know. There could be natural disasters across the world, and the whole technology cycle may get interrupted. Right? So, few million years ago, it happened on the Earth. We never know what can happen. There could be global conflict because this technology may be coordinated by only few countries or in the world, or it could be really global integration. These are some of the speculations which people are making out of different scenarios which people are proposing for the years to come. But one thing is very clear. The engineering development will always have these desirable features. One thing will be, it will be always well-being of the human being. So what that means is, over the time, engineering should contribute to the enhancement of prosperity, the happiness, and also the health. And the time affluence, that the way today people are spending a lot more time here and there, the time affluence should go down so that they can really enjoy the life. Second thing what engineering will always focus on is that there should be cohesion in the society. So engineering should always strive to make the society which is more cohesive rather than creating something which is more sort of segregating people in different domains. In that context, there's a parameter, what is called a Gini coefficient, which defines the disparity in the society. That thing should go down. That should be one of the objectives of engineering with the time. And of course, then we require the climate control. So the CO2 emission should go down, and the ecosystem and the protected land that should really rise so that we get the world tomorrow, right, which is going to be a sustainable kind of world there. So what that means is, the engineers first have to define their own future. That looking at these things which we talked about, if you have to create a society with all these well-being parameters and sustainable parameters and so on, we have to create our own vision. Others cannot give this vision to engineers. Transform engineering education to achieve that vision. So once we define that vision very clearly, we understand what the future of the world is going to be, then let us make the engineering and work towards actually realizing that vision. Build a clear image of future engineers who are technology leaders. At this point of time, what is happening is technological people are only the people who create the devices and gadgets and systems which can be used by people. But engineering and technology people still are not playing the major role in the policy making. And as the technology is going to dominate more and more in the society, I think engineers have to become technology leaders and policy makers so that the policy actually adopt right technology and steer the society in the right direction. Accommodate innovative developments of the non-engineering fields also. So there are many innovations which may not be in technical domain always, but could be at a social level. They should be accommodated into engineering program. So define ways to focus energies of different disciplines of engineering to the common goal. So first, as an engineering fraternity, we have to define what is our common goal toward the future, and all engineers have to work with that future there. There are predictions which are made by the UN, and some of the predictions are pretty scary, that by the end of 21st century, if you look at many of the natural resources and the natural growth which is going to take place in the world, these are some of the numbers which are projected by the United Nations. Firstly, the population is going to increase by about 50%. Right? So we are about 7 billion people in the world today. Maybe it may go about 2,000 billion right by the time, by the end of this century. The energy requirement is going to go by about 100% in next 60, 70 years. The electricity requirement is going to go up by 300%. And majority of these requirement is going to be actually be in the developing countries rather than the developed countries. The natural resources are going to go down by 80 to 90%. So the petroleum could be one, the coal is another one. So the sources, energy sources which you are having, like coal and petroleum, they are going to deplete significantly over next century. The food requirement is going to increase by 100% because the population is going to increase and the quality of life is going to increase. and the water stress population is going to go up by 200%. These are the projections which are made by UN. On the similar lines, the National Science Foundation of US has defined what are called the engineering grand challenges. Right? So first of all, can we make the energy sustainable society or energy sustainable world? So can we make the solar energy economical so that everybody can afford it? Right? Can we have control over nitrogen cycle, the healthcare, the nuclear power, the personalized learning? So there are so many things which are defined, right, by the National Science Foundation, which one can call as the grand challenges. And these challenges are to be handled by engineers and technologists, right? Because these are the ones which will be projected by the society, right? Policymaker will ask engineers what can be done and what could be solutions. And engineers will have to provide the solution and will provide the solution as the time history has shown. One thing is, of course, clear that if we talk about sustainability, then we should be talking about green engineering. So engineering as such should become, as a green concept should be launched into our engineering program. So engineering process and product integrate environmental impact assessment into the product development process. Conserve and improve natural ecosystem while protecting human health and well-being. So many technologies in recent years have developed. They have got maybe adverse health effects. Commercial drive which is there behind those technologies, the health aspect is not really considered. Even ecology is not really considered there. But in long run, if you wanted to make this, whatever development is there, sustainable, then we have to talk about integration and of this with the engineering. So essentially in engineering, then we have to bring the life cycle thinking, not only a product development thinking. So today, whatever product is developed today, it is seen at the time of delivery, is the product meeting the requirement. But if the product is going to remain there for 10 years, 20 years, then in 10, 20 years, the world is going to change, right? The requirement of the world are going to change. And in that process, how the product is going to sustain in that. So a life cycle thinking actually will be very important, right, in the engineering learning. And that is something which comes from the green engineering. Strive to prevent waste. Of course, engineers always are very frugal. They never overconsume the materials. But nevertheless, they should also see the least wastage which is possible and so on. And actively engage communities and the stakeholders in development of engineering solutions. And this is very important from the Indian point of view, that many of the solutions which we are getting from engineering, they are coming from the Western world, which are having a completely different society, completely different climatic conditions. And many of the things are getting imported in the Indian society, where Indian climates are very different, society is very different, their requirement is very different. But many of the things are getting imported, and they are creating some kind of issues, right, in the implementation as far as the society as a whole is concerned. But in green engineering will be the word for the future. So with this then, if you ask what is the current engineering education we are having? So firstly, the students are educated in a single department today. Right? That's what most of the engineering institutions are doing. Though the requirement is we should have a broad base, I think engineers are trained in a single department. Education as a whole is still the teaching centric. Right? So that means the information or the knowledge is given to the students, how much he understood, how much he captured, how much he implemented, that questions are really at the lower level. Engineering education has become teaching more, and this is a nice quote which I got from somewhere, which looked to me very good. It says now engineering education has become teaching more and more about less and less until it reaches to a teaching everything about nothing. And that's what is happening today. If you talk to an engineer, he knows a very, very narrow thing which he did. So if we talk about somebody working on some IT, if you ask him anything around computer science, he may not be knowing it. He will know only just implementation or what some ML algorithm or something like that. So what is happening in engineering today, since the information and knowledge has grown by multifold, the notion which is created is that everything has to be told to the students in 4 years duration, whatever he should be knowing in that particular engineering program. And since the information is really exploding, it is becoming more and more difficult to crunch the information right into the 4-year program. And as a result, what is happening is the students are not really learning the wide spectrum of activities in depth, which earlier engineers used to do. And there is a little exposure to the real life problem, especially in Indian context, we are getting more and more, simulation oriented thing. It may be because of the resources available, because of the financial concerns and so on. Nevertheless, modern engineering in India is becoming more and more simulation oriented rather than really the hands-on and the product development oriented. So wait a minute. Okay, so with this now, then one can ask a question that if you wanted to design now the engineering education, what the future engineering is going to be. So engineering education, as we said, it must be oriented towards the grand challenges, because ultimately the sustenance of the society or the world ultimately is going to rest on the technologists, scientists and engineers. They are the ones who have to find a solution for that. So if you orient the whole thing toward the grand challenges, you will require the energy, environment, global warming, sustainability. These will be the focus of engineering. Improved medicine and the healthcare delivery, reducing vulnerability to human and natural threats, and expand and enhance human capability and joy. These are some of the things which have to be integrated into the engineering education system, so that when they graduate and go out, they are fully aware of all these issues which are there for the engineering program. Secondly, the world is becoming more and more global. So we have to make the engineers now which are global engineers, because the influence of global changes are taking place. We cannot now talk only about the zones, your own local zones or local countries. The entire thing is going to be across the world, because each world, every location of the world is aware of what is happening in every other location of the world. So information and communication technology in last century essentially has created a world which is a flat world. So engineering is sensitive to global issues because it has a common international language of science, maths and technology. And everybody is aware of what is happening at every corner of the world, right? And that creates some kind of expectations, of the societal development across the world. Secondly, the engineers have to deal now with multi-ethnic, right? Because many jobs are going to get outsourced, right? So it's not that you are going to work always in your own country and so on. You will require multicultural and multilingual aspect, particularly in India. You will require that because somebody goes from one state to another, all the multilingual and cultural problems come there. And you have to create the engineers which could be globally competitive, but they have to be locally relevant. So many times you might be working on technology which are very, very globally competitive, but those technologies are actually developed for the modern world or the advanced world. Many of the technologies are not directly useful to the local community. Right? So in that context, I had one Sam Petroda's quote, which is a very interesting quote. He said 90% of the world is busy in solving problems of the 10% of the world who actually don't have any problem, and which is really true. If I look at the technology development today, many of the technology are actually developed for the people who are already in a very, very affluent state, right? But still, because of the commercial reason, this technology developments keeps on taking for these people. But so our objective has to be that we want technology which has to be really at the world cutting edge, but that should have a direct implication for the local community and the development. So the future engineers will need, and this is even from the NBA point of expectation, it will require rigor of engineering knowledge. It will require critical thinking and understanding, because knowledge is going to be now more and more available in the digital form. Employability and lifelong learning, right? And most importantly, from the Indian education point of view, the quality culture has to get built in our engineering system. Today, we produce the engineers every year, which are almost equal to the population of many of the small European countries. But if you look at the engineering impact in that proportion, that is not commensurate with that kind of expectation which you can get from there. And that is primarily happening because the engineering has become the easiest option to really get into the system. So today, if you ask the student who has finished 12th, what is his first choice? He will say first he wants to be large. There is an acute shortage of the faculty in engineering, and the quality certainly is getting compromised. So in future, our engineering education has to focus primarily on developing the quality engineers. If I look at the multidisciplinary education, which has been proposed by NEP 2020, that say I'm an electrical engineer, so I don't know anything about mechanical and vice versa, and many other things there. What that means is that we require some kind of a restructuring in the department. And that's what NEP 2020 also proposes. That more flexible, that's what NEP 2020 is proposing. What that means is it should become more learning centric. The student should decide what he would like to learn rather than available across the country, so they can use, not only within India, not only within their own institution, across the world, they can sort of access the resources and can become better engineers. There's a concept of major and minor proposed, that many times students get into particular engineering discipline and then they find that, well, that's not the discipline they wanted to get into. So there should be some opportunity available for them to really do some engineering in their liking, in the discipline of their liking. So the concept of minor has been proposed. Exposure to societal problems, and this is something which is very important. I think the engineering education should start exposing the student to the societal problem. Let them know what problems are compared to what you see in your curriculum or what you see in your textbook. Then we have to inculcate the design thinking. That's what NEP 2020 says. And there has to be integration of knowledge, not only within engineering, but across the different disciplines, including the science, technology, and the arts. Another thing with the NEP 2020 has highlighted is the technology enhanced learning. Why it is important? Because as the time is moving, that education has to become more and more learning centric. And as I mentioned earlier, that means the teacher, as the time is moving, the engineers also, irrespective of which discipline they are from, they have to have a digital literacy. And what digital literacy means? They should know how to access the material, knowledge. The time is moving, and that is, people should be able to access those courses. So each engineer should be able to add on the digital platform the new knowledge. At the same time, you should be able to consume the knowledge which is available in the digital form. Virtual classrooms and virtual labs, they are already being implemented. There are some different stages there. We are having, and the flipped classroom concept, people have started implementing it in education and so on. And then we got a lot more software and simulation tools, because now the computation power cheaply available. So many of the systems can be located in very prime institutions, but if they can be made accessible by other students, through the ICT technology, then they can operate those instruments even remotely and can get a feel for implementation. So technology enhanced learning is something which every engineer will be playing a big role with. Another important thing which is there is that engineers now, since cannot work in isolation only on technology and science, they should understand the society also equally well. Because ultimately, whatever the engineering they are going to develop, it has to be deployed into the society, and society should accept it, adopt it, right, and give a proper feedback for the development. So liberal art education is going to play a very, very important role in engineering. And in that context, I think in India, when we develop this technology university, engineers who do not have great the sense of the societal problem. Even those courses which are humanity and social science courses which are there in curriculum, those courses are taken by the student only as a burden. Whereas for developing the ethical system, ethical values, and finally we require something what is called sustainability, which has to be brought into the engineering curriculum program, which at the moment is offered as a subject, but which is again like first year level, some subject is taught about sustainability, and then students just forget about it. In fact, this sustainability and has to be repeated again and again at every level in the engineering program. So whatever they developed in the engineering curriculum, I think they have to see from the sustainability point of view. Innovation and entrepreneurship, I think, has been said repeatedly by various people, by government, by technocrats, by the scientists, by engineers, everybody, that we have to build the entrepreneurial mindset among the students. However, this is easier said than done. In engineering curriculum, when I look at it, the entrepreneurship or innovative mindset requires unconventional thinking. Whereas when I look at our curriculum there, our curriculum does not encourage unconventional thinking among the students. Whatever has been there, so our thing, whatever we are having with us, at the moment, it simply tests your reproduction capability of whatever has been taught or given in the curriculum. Unconventional thinking always requires more time in the curriculum. So our curricula which are there in engineering program, they, with the time, I think they should get less and less loaded. And there should be given more free time for the student to think so that they can come up with very unconventional ideas, right? And which can be now tried and seen how the ideas will be society, which will be sustainable society. And this development which is going to take place, that has to be mentored by the industry. Because ultimately these ideas which are going to come, ultimately these ideas, unless they are translated by somebody for the societal benefit, those ideas will remain only at the thought process level. So industry have to take this idea, matter, you fail today, but tomorrow you try it, tomorrow you may really try to do the research, right, which can give you some publication, positive result, but we never try something, which will fail completely. And if the idea fails, you can get, a new idea, right? So it has to become learning centric. Lifelong learning should become really the buzzword. So that means everything we don't have to teach in our curriculum. We have to teach the students how to learn. And if they are taught how to learn, they can always learn later on their own, right? Because the resources are available, where material can be made available. They should be also made to the exposure to the real life problems, right? And this can be done with the help of industry, corporate, government agencies, right? And so on and so on. So many of the programs which the colleges run, like NSS, those programs should be used for exposure of the societal problem to the student. So during the NSS program, students maybe should be asked to go to the society. They should go to the remote villages, remote places, and see what are the real societal problems. And can technology and science, engineering could be a solution for them. They may not solve it, but at least they can identify the problems, and those problems then can be handed over to people who want to take it forward and can become entrepreneurs and so on and so on. Very importantly, we have to have this change of mindset which we require. We require mentoring of teachers. In fact, in engineering is the only probably discipline where the teachers are assumed that once you have got appropriate degrees, you automatically become good teachers. But with this new thing which are happening in the education sector, right, in engineering particularly, you have to really create a different mindset for engineers. So teachers are not going to remain only the mode of information transfer. The teachers have to become now more mentors because the information is available. Students can always get the information from the internet. So then what the teachers are supposed to do? The teachers are supposed to build on that knowledge which the students have, right? So they should be open. They should be discussing with the student, right? They should be talking about failure. They should be talking about new ideas, how they can be mentored and so on and so on. So teachers' role over the years has to change, and they should become more and more the mentors. The use of ICT to complement teaching learning process, right? And that's, whether we want it or not, this is certainly going to happen there. One big thing which we require in our engineering education is the examination reform. Our examinations are certainly not made for testing the knowledge in a particular subject. And people who are sitting in IITs and ISC may be thinking that most of the time we set the examinations, where we test the knowledge of the student. Once we go outside IITs and ISC, we will see in most of the colleges and universities, the examinations are set in such a way that there is no testing of the knowledge or understanding of the subject. It is practically reproduction capability, right, which is built into the system there. So we require really a big examination reform. And by doing this, there may be a possibility that for a while, the success rate of engineering graduates will come down for a while. But then the graduating students slowly will get accustomed to this pattern of really developing in-depth knowledge and not only reproduction capability. And when that happens, then you will have really the true engineering impact which we require. So there was a IICT committee which was chaired by Dr. BVR Mohan Reddy. He was NASCAM chairman that time, I think. And that time he identified certain engineering skills which are going to play a role in next 20 years. And these skills are going to increase like cognitive abilities, system skills, complex problem solving, the content development skills, the process skills, the social skills, the resource management skill, technical skill, and physical abilities. And out of which essentially the cognitive abilities are going to be the maximum, right, in this domain there. So as the time moves, I think the preparation of the student has to become different, right? If they should not be now prepared just to score the marks in the examination. They should be now prepared for what the industry is going to need there. The new technologies which are going to come in next 25 years, which are again predicted by the business houses. Many technologies, or 25 technologies they have identified, which are going to dominate the engineering in next 2 decades. And some of them are actually already have started showing their presence in the today's life. The artificial intelligence, we are seeing it, machine learning, we are seeing it, Internet of Things which is coming, big data and augmented reality is coming, cloud and edge computing is coming, virtual reality is coming, the natural language processing is there, robots and cobots are there, cyber security, the quantum computing, the robotic process automation, 3D printing, and additive manufacturing. Many of the things have already started happening. So though they say these technologies are going to dominate next 2 decades, maybe as the history has shown, maybe the technology growth is going to be so rapid, many of the things may get exhausted in the next 10 years. And we will not be able to predict what is going to happen after 10 or 20 years, because this technology lifetime is only about few years. So it is very difficult how the life is going to be after about 20 years. So when you talk about engineering research, essentially we are saying that we should be having a combination of the fundamental understanding of the natural phenomena of science, but its application should be there for the human application. So for this to happen, we need a very strong industry-academia partnership. Now, what do I mean by that is, at the moment when it is happening more like a sponsorship coming from the industry for research. Many times the money comes for the CSR money, and by doing this, when money is given by the industry to the academia, invariably the industry thinks this money has been written off. So money is given to academia because they have some responsibility. So money was given, they never thought they should get any returns on this money. I think this mindset has to change. Industry should start expecting something from the academia, which is very tangible, which can be translated, right? It can be converted into a product. At the same time, academia also should realize that they should be doing a research, which is not only doing for sake of doing research, but which should be translatable so that the industry can take it forward, right? And get convert and monetize it. So complete the cycle of knowledge to the money to knowledge and knowledge to money generation, the cycle process that should be established there. So universities should become the R&D houses of industry. So not the sponsored project given to them. The industry should say that, well, we are having intellectual capital here in the academia, and the entire R&D base can be shifted now to these big, the academia universities, right? And the research can be done in the partnership. So industry and academia both understand what is achievable, what is doable, why it fails, why it doesn't fail. And then this partnership can be a win-win partnership for academia and industry both. So just to summarize then, the future engineering education then should have the diffuse boundaries. So the engineering has to become more multidisciplinary, is one. Second, globally competitive, but locally relevant engineers have to be produced. Third, technology enabled and lifelong learning has to be emphasized in your engineering program. Strong industry academia partnerships have to be developed so that the knowledge can be converted, it can be monetized, and it can be converted into products. Application-oriented curriculum and research, that should become the core of engineering. teamwork, handling failures, entrepreneurship, that should become really a core of your engineering program. Sustainability to be at the forefront of engineering. Because without sustainability, we will not be able to take it forward even beyond this century if we keep on moving the way we are going. So engineering will play a major role, right, in this sustainability aspect of this century. And liberal arts should integrate in engineering program. So to prepare the engineers to play greater roles in the policy making, because the world is going to be dominated by technology, and to understand that, the engineers will have to start playing an important role in the policy making. So the motto of the engineering, that if you want to summarize, the motto of the engineering should become advancing technology for sustainable humanity. So we know that technology and engineering was always for humanity. Now we have to add another word there, that is sustainable. And when that happens, then we can create a world which is really progress, which can be sustainable, and our generations to come, they will really enjoy the same benefits of the natural resources which we are having there. So thank you very much. Thank you for listening. And if you have any comments, suggestions, you're most welcome to give the suggestion. Thank you so much.
Yeah. Thank you very much, sir. There are a few questions in the Q&A box, and I will take one by one.
Right.
Yeah, sir, the first question is, in all this explosion of technology, IPR issues disfavor wide learning and exploitation in different countries/communities. How can we bring about a reasonable environment for transparent spreading of technologies which have been arrived at?
Yeah, so the IPR issue is a very, very sensitive issue in some sense, And the IPR issue actually came because everything which one wants to do, we want to monetize it. But there is also a movement which is for the open source kind of movement which is there in engineering and technology. So whatever technology is there, if the objective is that it should go to a wider community and as many people as possible should really make use of it, rather than cornering in the technology and making money out of it, really huge one. I think slowly these IPR issues will get solved there. But that requires a mindset change, that only few people in the world should not corner the technology and exploit the remaining world. Unless their mindset changes, the IPR war will keep on happening.
Sure, sir. Sure. Thank you, sir. Next question, sir. How to inculcate human values in today's engineers? For the societal connect and solving societal problem, one should be sensitive and own the ground level issues.
Right. So first thing that I mentioned in our engineering program, first of all, we should expose them to really the societal problems. So let people go and see what are the issues which are there in the society. Second thing, that we should, so what we normally, today, when we go to the students, we ask them, what would you like to be? Invariably, the answer comes, I want to be a professional, I want to become a millionaire by the end of decade, I want to retire before the age of 30. These kind of answers which you will get. They also have the models in their mind which they want to emulate. And these models are only the billionaire models. That everybody wants to become only billionaire. What ideally should be, first you should tell to the students, irrespective of what your discipline is, first you have to become a good human being. Then you have to become a good citizen. And then you should become a good professional. If you start reversing this order, then of course you are going to create a society which is very different. So the human value inculcation has to take place not only in the classroom, it should take place in the outside the classroom. In fact, it should take place even outside the education system. So every house, every part of the society should be building this new value system where the societal values are more and more important. And it is not the only money which is going to be important in life. So this value system, unless we integrate that in engineering program, and for that matter, I would say in any education program, we will not be able to develop the society, right, the kind of society which we want. So this is an exercise we have to do deliberately with great effort so that our value system has to get established, which we have eroded over last maybe couple of decades, and we have come to a level where only the commerce and the money has started playing more and more role.
Sure, sir. Next question, sir. What is the potential of augmented reality and virtual reality in the current and the future engineering education, sir?
See, it is happening there already. So there are virtual reality which are already there, right? And it is going to increase as the technology is going to happen. So maybe conceptually at the moment there are not too many problems. The problem are the implementation, the kind of bandwidth they will require, the technology they will require, and so on. Right? So over the time, I think the virtual and augmented reality is definitely going to play more and more role in your even real life problem, right? So there is no escape from that. Whether we want it or not, I think technology has already gone ahead significantly, and it is going to make the transformation where you are going to have the virtual reality in your real life.
Sure, sir, sure. So probably one last question, sir. In view of rapidly changing technology, how should the curriculum change or be prepared to be in pace with this rate of change of this technology, sir?
Right. So first of all, I think when you look at the curriculum, normally what happens, that every college, every university is trying to teach the student the only advancement which have taken place. The advanced subjects, they give emphasis on that. And over the time, if you look at our engineering curriculum, the fundamental courses are getting lesser and lesser weightage. That's what is happening. In fact, this is exactly opposite we should be doing. We should be teaching the students only those things which are reasonably time invariant. These things are not going to change, over even 100 years. So if you are teaching somebody good thermodynamics, I think maybe the engine cycles and many other things might change over time. But if you understand thermodynamics properly, right, later on new technology, he can adopt very easily. If you understand electromagnetics, no matter how much communication technology changes, if foundation is solid, he will be able to do that. So my suggestion is, we should be teaching the students only the foundation courses, much more in depth, and so that they can be prepared to adapt any new changes which can take place in technology. And it is very easy if your foundation is very, very solid. Within no time, you can adapt to the new technology. But if you learn only new technology, the technology lifetime is only a few years. After 4 years, if the technology is gone, you feel you don't know what to do now. So foundation should be more emphasized in the curriculum so that students can then become self-learners, right, for the new technology adoption in later part in their life.
Sure. Sir, Professor S.S. Murthy has raised a hand.
Yeah, sure.
Professor Murthy, over to you, sir.
Yeah, it was an excellent presentation, Shevgaonkar, and I'm presently in Montreal, and it is 7:40 here, and I got up early. I was keen to listen to him because the subject is of interest to us. A few issues. One other thing is, some of the technology which was there in ancient India, which built temples, which built shipbuilding, textiles, and many things were there. I think it was somehow systematically downplayed after the foreign domination, I think. I think somewhere there should be a way in which our engineers and students must be told about these things as a part of education, because even before Newton's laws, many things were there. Even in our earlier scriptures and things like that. That's number one. Number two, I think we need to have a great revolutionary change in our admission system in engineering. And this coaching industry's annual turnover of nearly 2 lakh crore, that is the annual turnover, and that is destroying the whole education system per se. So I have and I think just like NEET, at least engineering, I think we should start off with one nation, one entrance test. I think, and let the NTA handle it, and IIT should get out of all this conducting the entrance test. I don't understand the reason why NIT you need one entrance test and IIT you need 2 entrance tests. I have nobody has convinced me. It's all waste of resources, waste of money, waste of IIT's this thing, etc. And anyway, so you have already covered the things about the NEP and other things. And I think, you have rightly said that we should integrate our engineering education to society. I think we should think of a very large enhancement of internship system, internship of our students. So beyond classroom, a lot they should be made to learn. I think they should take internship in society. I think not just in industry. They can even go to a hospital, they can go to a village. And I think, we need to have quite a revolutionary change in engineering education system. And last but not the least is the teachers. Teacher is a big weak point in our education system. Actually, nobody wants to go to engineering teaching nowadays. That is the problem. And now if you want to run a flipped classroom, for example, you need a large army and band of dedicated teaching assistants. And I think, you have made very wonderful suggestions. My only concern or point is there should be a mechanism to implement these suggestions, and we should start this implementation immediately and today. Okay, thank you very much. These are
Thank you, Professor Murthy. I think those good points. Coming to your first point, which is about the ancient knowledge, my suggestion would be, let us take the ancient knowledge, let us put out the framework of the modern science and optimize those things. Maybe many things were working that time. Yes. But with the better understanding of scientific principles, we can make them better with that understanding there. So of course, we should be telling our students what was our ancient knowledge, but now we should tell them also how that knowledge can be sort of refined in the today's framework of science and technology. So that's what it is. Coming to your selection process, I think our all engineering admissions are not selection process, they are elimination process. Right? We eliminate people who are not performing on that particular day of the examination. That's what we have been doing. But we don't have any better mechanism because of the number which we handle. So we know the problem, probably most of us, but we don't know how to really solve the problem. But you are absolutely right. We have to solve the problem. I agree. Thank you.
Sure, sir. Thank you very much, sir. Thank you very much, Professor Murthy. So if there are no questions, we would like to take this opportunity to thank Professor Shevgaonkar for a wonderful talk and for accepting our invitation. We would also like to thank our audience who have taken time out of their busy schedule to come and make this Samvaad a success. Updates of the subsequent editions of Samvaad will be posted on our IIT Dharwad website. We request you to keep a tab on that. So thank you all and good evening and have a wonderful day, sir. Thank you. Thank you very much.
Thank you.
Nice seeing you.
Thank you.
Bye.
Professor Munjal, you should also give a talk on this forum.
Pardon?
We would like to hear your speech also one of these days on this forum.
Yeah.